So it's very important. I mean, it's worth repeating again. Hydrogen by itself, it's not flammable. Oxygen by itself, compressed in a tank, it's not flammable. It's only when the two come in contact. And you see HHO, that's why it's implosive, explosive, and it also has many different types of ranges it can be at, depending on how much oxygen it comes in contact with. It can either come from the air, it can come from here, the pure oxygen that you're creating on that plate over there. So if you had hydrogen all by itself over here, you know, just hydrogen, okay, it would have to get the oxygen out of the air here. It would come out at the end of the wand, out of my torch, and the hydrogen would burn, and it would burn up the oxygen in the air. See, the real blessing is the water provides its own oxygen, okay? So it's very important. This atom by itself, it's very important. The proton, the neutron. We're going to go over here and take a look at this real quick. I'm going to put this in here towards the end of the video so you can see it. If you can read that. It's very simple. Remember, like charges repel, opposite charges attract. It's very simple science. You know, talks about electrons and free electrons in this book. You know, many trillions of electrons can be resting on a surface. That's how a capacitor works. Okay? So I thought I'd cover that in this book. I'm going to add this to the video. It's kind of a bunch of chopped up videos added together. So I hope this helps you. You know, electrons can be dislodged many different ways. Friction, light, heat, chemicals. You know? See? Glow stick. I broke this glow stick and it's glowing. Where's the light coming from? See? This movement of electrons. Positive ions. Negative ions. You see? Normally it has its electrons scooting around the hydrogen atom, but if it loses it, it becomes a positive ion. See? It becomes positively charged. So it's very important that you understand that. So we're right back in here, part 2, back to basics again. I'm going to show you guys a little something here about the basics, okay? I hope you can read this. I'm going to put it in view. You can just go back and pause it. Okay, now this lithium atom right here, okay, electricity, the electron, is an essential part, okay, of atoms. This is 21st century fire, guys. This is what we're all after. You know, this is that negative electrical charge, that electron, that subatomic particle, that is so important, you know, it runs all of our electronics. Okay, this is how we power our society, using electrons, electricity. Okay, so it's a very essential ingredient to atoms. Okay, some of you asked me what electrolyte I had in there. I'm using sodium carbonate. Okay, so just in case you wanted to do it just like that as I was. There you go. I have sodium carbonate in there, 1 teaspoon. Okay? Just for an example, I just wanted to show you guys this. Okay? You know, I have my oxygen atoms on the left being produced by the anode, and my hydrogen atoms on the right being produced by the cathode. So the negative side's always going to produce hydrogen in every cell you ever build. Okay? You got to remember the oxygen side. That's a very, very unstable atom at that state. Once it becomes an oxygen gas, it's corrosive. I mean, that's where all the iron comes from, the rust. A lot of people don't know that the positive electrode, okay, will corrode. It will dissolve. It will fall apart. Even this one, all of them will over time. Some of them have different times, different lengths. Stainless steel lasts a really, really long time. I mean, I've had cells last for years, and I ran them really hard, and I opened it up, and I can't believe how little damage there is, but you make a lot of rust, okay? Stainless steel is a combination of 3 metals. It's copper, iron, it's a mish metal. It's a lot of things mixed together, okay? See, this carbon fiber electrode is not like that. This is pure carbon fiber, okay? It's advanced material. This is what I've started making electrodes out of. Okay, this little one on the right here, you can just get that out of a battery. Okay, I got that out of batteries. I cut open old batteries and get these electrodes just like that. Okay, but these fall apart really easy too. After you run it a while, you'll notice that it starts to get a lot smaller. Okay, so your electrodes disintegrate. A lot of people don't know that. This has a lot to do with electroplating. You know, the process that's going on here is very powerful. Okay, anyways, let's go back to basics here. I wanted to cover the rest of this in part 2. Now you've seen the hydrogen atom. You understand when it's in an atomic state like this that it's an unstable atom. You've removed electrons. Okay, I hope underneath here I can help explain it a little more. See, now your oxygen atom. Okay, let me get this in the picture here so you can see it. See, these are unstable and they're on the table of elements in their atomic state. Like I told you, these things aren't just lying around, okay? You're not going to find oxygen and lakes of hydrogen and lakes of oxygen just walking down the street, okay? These things are covalently bonded with a lot of things in our environment, okay? So they're two sociable atoms that are connected with other atoms. They're not just lying around. So when you break this water bond here, you have a magnetized gas. I could get a big magnet and come up here with a big magnet and you can pull these bubbles and push them. Okay, so you have two gases that are oppositely electrically charged. Okay, when you form a water molecule, they have the net charge of 0. The whole thing becomes stable. Water is a very stable molecule. Okay, you know, think about that. We have the stability of water and the power of the sun right here. You know, it's not volatile like gasoline or butane or propane or a lot of other things, alcohol. You know, water's very stable. It's very stable. You can dump it on you. It's not going to catch fire with a lighter. You know, you have to use electrolysis to get anything to burn. Okay, so it's very important. I wanted you to understand that. See, the hydrogen atom here has a positive, the ears are positive on this. And you're like, well, how did that get positive and how did that get negative? Okay, well, it starts like this. Originally, the oxygen atom, when it's by itself, okay, here's its electron outer orbital shells. There's these electron holes. That's what's important. You have to remember that, okay? Because what happens is your hydrogen atoms come up and they share a covalent bond, okay? I kind of made this up so you can understand what's happening there, and that forms your water molecule. And that's how these get thrown into a positive state. Because of the pull of the oxygen atom. Its proton turns these positive and it turns the oxygen atom negative. Okay, it looks like this. Okay, that's what's happening. That's how your water molecule is being formed. Okay, and if you look at it, it's oppositely electrically charged. But the atoms here, they're oppositely electrically charged, but when it's in a stable state, there's an imbalance that occurs. Because of the way this pulls together. See, the magnetism, you have to understand that down on this small level. Okay? I'm going to show you right here missing electrons. Remember I told you about the missing electron hole? Okay, in the orbit? So these rush in to fill that hole. Okay? And then it becomes a stable molecule. Otherwise, when these are separated, they're highly unstable atoms. And they can become pushed even further stable if you remove even more electrons, depending on what you do. And remember, the neutron has a lot to do with stability. That's a whole nother subatomic particle. We're not dealing with that. We're working with the proton and the electron. Okay? Now remember that. Okay, I'm going to cut this and I'll add a little more to it. So you can clearly see the opposite electrical attraction force that's taking place here with the water molecule. Okay, study of the hydrogen atom helps us understand the cosmos. You understand the bigger stuff by studying the really small stuff. Okay, that's what I'm trying to show you guys. You know, big things have small beginnings, and the hydrogen atom is one of the smallest things in the galaxy, in the universe. Okay, it's very small. See this stainless steel knife that's in here? See, it's on the cathode side, so it's going to look like that 100 years from now, just like the way it was when I put it in there. But the positive side, you see this carbon fiber is tough, but it won't last forever. It's almost as hard as steel. Carbon fiber is very strong. Works very well as an electrode. Okay? The reason I do it like this, I was teaching it in this video, I wanted to show it this way and a couple other ways using carbon fiber and things like that, because I wanted to show you different electrodes and the different results that you get. And so you can see some at the bottom here how this corroded and fell to the bottom, but it didn't leach out any iron. My water's still clear, you can see straight through it. Okay, just trying to explain some of this stuff to you before you guys get into the more advanced electrolysis and I start showing you some of the reactors and how they run. You need to understand this electrical attraction force and how these atoms become like this to begin with. Okay, you can learn a lot from this. It's how the universe was made, and that's where we come from in our distant past. You can see into the future by studying this stuff, understand where we come from. So you can see the atoms are very fussy about their electron shells. Okay, they'll do anything to fill their outer orbital shells. Okay, especially their outer shell. If this is missing an electron, it's very reactive. Okay, understanding the subatomic particles that make up atoms, understanding the table of elements. Okay, see the oxygen atom. I mean, I don't have to make a whole nother video covering the oxygen atom, but it's kind of hard to talk about the hydrogen atom and the water molecule without referring to this. You know, atoms are very fussy about their electron shells. It will do anything to fill their shells. So other atoms rush in, okay, to fill the voids. That's how this is happening. This swings to a negative charge and these become positive. And it has to do with this pull right here. This covalent bond, the electromagnetic forces right here. Okay? So I try to put this in layman's terms so some of you could understand a little better of what's happening here and how this all works. Okay? So seeing how the water molecule was formed in the first place tells us a lot about how you can break it apart. So it helps you understand how to break it apart in this simple electrolysis process. Don't forget about the table of elements. These are the building blocks of life. This is for every creator out there and every inventor. This is what you have to work with. These are all the known elements known to man. And these are two of the most precious atoms known to man, oxygen and hydrogen. It's very important. If you're going to build oxyhydrogen fuel cell reactor cores, you need to know what to build it out of. Okay? Choose and build and create wisely. You know, you're building materials, you're limited to a few things if you don't know what you're doing, but if you study the table of elements, there's all kinds of stuff to work with. Platinum's one of the best electrolysis materials, but it's expensive and it's kind of hard to get your hands on. But there's plenty of other things to work with that don't cost as much. I spent $10 on this carbon fiber electrode. This thing's hard as steel and it's long-lived, so something to think about, working with other metals, working with other things off the table of elements. Okay? This sums up this video. This was a two-part video on the hydrogen atom. I tried to do what I could to explain it in layman's terms for some of you guys so you could see what was going on here. Okay. One way to prove all this out is you could take a glass of water, stick it in the microwave, okay, and turn it on, and you'll notice that the water heats up, and the way it heats up is because it sends out an electromagnetic wave that oscillates these water molecules. Okay, they start jiggling around in there, and that friction is what creates the heat and boils the water. Okay, they oscillate very rapidly inside of the microwave. So it's one way to prove all that out, to show you how the atoms are moving around, and they move very quickly with this positive and negative electromagnetic force that is on the water molecule.